Hello, guys. First, first, I'd like to make an apology. The original speaker of this topic, Zhou Xiang, he can't be here for some personal reasons. I will share this topic to you as a substitute for him. And sorry again that we can't provide a QA session after this topic. So I will leave you an email address. If you are interested in this topic or you have any questions to ask, you can send email to him later in the day. Okay. My name is Len Xi. You can call me Richard as well, a solution architect from T2 Cloud. Before we started, let's take a few minutes to know about our company, T2 Cloud. Our company's core team was built in 2011, and we published and released the first public cloud version based on OpenStack version E in the next year. Our company was founded in 2014, invested by some famous investors in China. And we are the pioneer of industry cloud in China right now. We have built some industry cloud product for finance, for railway, energy, and television and broadcast industries. In this topic, I want to share you some experience about database performance tuning and on the large-scale deployment of OpenStack, like our China Railway project I will introduce to you later. Okay. Database is the key component for the OpenStack services. Most of the OpenStack projects have to communicate with the database through Oslo. As all the database connections as treated as transactions, which it can't be easily to differentiate from which connection is or which transaction is about read request or write request. So it's hard to do load balancing nowadays. In this topic, I want to share you or give you a way to improve the whole system performance by optimizing the software rather than by purchasing some expensive hardware to make the system perform better. Okay. So I think it's a valuable topic for the real world. First, I want to share this topic into 4 small sessions. First, I want to show how to analyze the performance of the database and narrow down what is actually the bottleneck of the database or the whole system. Then I want to show you how to split the read and write request from the services of OpenStack and to route them into different servers. Third, I want to share you some software configurations and the system tuning to tell you how to make the performance better. In the last session, I will show you a conclusion of the result of the fine-tuning. Okay. Sorry. Sorry, here's some problem with my PowerPoint. Wait a minute. All right. Nowadays, modern software is usually integrated with some probes in the source code to help the developers to trace the program real-time behaviors. MariaDB and MySQL also have the ability to support the probe detections. System tab is a useful tool to help diagnostic performance and functional problems for the software. With system type and some custom scripts, we can dig into the details and find out what's wrong with the software, which is hard to understand from the appearance. So through this, we can also get a batch of information, such as collecting the most hot tables, like most read and most write, and the query latency and the detailed log time. We can get those informations. And we use system time to detect the behavior of the database, like MariaDB. Then we analyze the result with flame graph to find out the underlying performance issue. We can find some useful probes in the source code of MariaDB. You can find it from the GitHub. Some of the probes can help us to trace the database behaviors. In the next slide, I will show you some examples using this query probe. Yeah. Here are the data which is detected and pushed out real time from the probe of MariaDB. The gap between the query start and the query end means that is the whole query time of this SQL transaction. And as the source code I have shown in the last slide, we can get the detailed information of this whole query. And with our custom scripts, we can know what is really going on with this query. As shown in this screenshot, we can see the parse latency took 7,000 microseconds. And this is a simple example to get the parse latency of the query. Also, you can analyze the database behaviors with your own logic and with your own custom scripts. With the custom scripts, we can trace the specific database, and we can trace the details of a query from the parse stage to run stage. Here is an example which is heartbeat. A heartbeat query we detected from the server end, and we can see the query cost a lookup table cost 2 microseconds, and the whole process cost almost over 700 microseconds. And flame graph is another feature of system type. I think some of you may be familiar with this one. Flame graph is a visualization of profiled software, allowing the most frequent code paths to be identified quickly and accurately. So it's a SVG formatted graph. So you can zoom in and zoom out to check the details of the whole data to chase the performance of or to chase the performance issue of the whole services. We can collect and convert the system type outputs into flame graph like this one, and this can help us to find out the hit rates from the different OpenStack services from the whole system. From this slide, we can see that the keystone and sorry. All right. You can see keystone, neutron, nova. They caused the most queries, or they are the hot table of the whole system. And from this graph, you can see that select caused a lot of is the most part of the queries. I've summarized the flame graph to a pie chart For easy look, I think. Let's check the statistic of Nova query. This is a proportion of Nova query Nova queries. We can see that the read, or we can see select query amounted over 60%, and of all the requests. And let's take a look to the Neutron database. The number even reached up to 82% of all the queries in Neutron component. So that's incredible. It's a big, it's quite a heavy work for the database. Let's take a total look. We can see that the selection, the select operation reached over 70% all around the queries. So we can get a conclusion that the most request of the database is read behavior rather than write. The most thing we need to optimize is about read. If we can leverage the read operations to different nodes, maybe it can improve the performance of our whole system. Now we have known the real OpenStack database workload. The next, I want to share you the way how to split the read and write workflow into different services. In traditional deployment of OpenStack, MariaDB cluster always hide behind the load balancer, like this one. The official document of OpenStack community also recommend us use the master backup mode to avoid deadlock, but it makes the master node as the hotspot. If we want to leverage the workloads to different servers, this may cause the deadlock issue. So in this slide, we can see that deadlock happens in the Galera cluster with a master and a slave mode. In this picture, we can see that two threads want to update the same row simultaneously. As it happened, the load balancer leveraged two requests to different nodes, which return the same row for update. If the update request of the thread A commit first and sync the bin log to another node successfully, the sequent update request of thread B will return deadlock error because the data inconsistent. You can see more details from the bottom following links. To solve this problem, we introduced a database middleware named MyKite, which is proudly released by Chinese team of Alibaba. You can see that MyKite provides a lot of functions, like support multiple type of databases, like MySQL, like MariaDB, and support Galera for MySQL and MariaDB cluster. And it can provide database sharding for some featured tools. Okay, with MyKite as our proxy for the database, this is the architecture of our improved solution. The proxy cluster responds for split the workloads and keep alive, and HA proxy is to help the proxy cluster in high available status. If there is a MyKite node down, the workload will be guided to another one, like the other one. The cluster will still available to handle all the requests. We also did some works on the sqlalchemy to differentiate which the request is about read request and which is about write request. Then MyKite can route the write request to one of these MariaDB server exclusively to avoid deadlock happens, and balance the read request to all the MariaDB clusters for better performance. The underlying structure might be a Galera cluster or SQL group replication, and you can choose any of them to deal with the data replication. Frankly speaking, the most important the improvement is not easy for us. I think it's hard to identify the operation query as read or write, since all the requests are wiped by sqlalchemy as transactions. So our DBA have done some hacking to change the transaction context and make sure the proxy knows who is or how to separate the request. Okay, in this session, let's look into how to make the configuration, including the system tuning. This is an example about server configuration of MyKite. It's defined in it defines the JVM, Java VM parameters, and the authentication method used by the application. It's just a simple example. Okay, this is a simple configuration of a MyKite policy, which defines how and where will MyKite route the request to. It gives you the ability to a lot of cool stuff, depends on your requirements. You can see here are the configuration lines about the real servers who will respond for the write request and who will respond for the read request. The database configuration is always a challenge for system setup. I will give you some suggestions, but actually it usually need to be changed. Based on the real business workload, such as open file limit is an important one, which the database read or flash the records. Well, the default value is only 4096. Is too small for the real world. And the default connection and the cache set is also an important one. This may lead to severe negative effect when the cluster is holding a large amount of query operations. So we have enlarged the data to meet the requirements of the business needs. Okay, from this screen, you can see that the read request and the write request, we are separate to different services. Oh, from this picture, you can see that we use sqlalselect to verify all the selected requests are separated to different services. It means the setup has worked. Okay, that's the last part of this PowerPoint. Based on the fine-tuning, we have successfully passed the stress testing in our project of China Railway Corporation. You can see from this picture, we performed the test based on three controller nodes and over 600 compute nodes and about 100 storage nodes. Based on this environment, we provide over 100,000 virtual machines on this platform. It's quite a challenge for the whole systems that such amount of these machines will cause a lot of SQL queries to the database. So we have made a lot of work to make the performance better. Also, we have made some scalability tests and high availability tests, like cut the entire power of the rack to prove the stability of our product. Okay, thanks for listening. And this email is about our engineer, our developer, Zhou Xiang. You can feel free to ask some questions to him. And that's all. Thank you.